Hello and welcome to the presentation on digital pump controllers for booster and transfer sets. I'm Paddy, your host tonight, and I'm going to tell you the features and how to use and the benefits of using this latest technology control panel. To begin with, the control panel has a built-in onboard computer for all the control as well as user interface functions. It has a built-in switchgear for starting and stopping of the pump. It also has complete protection features so that whatever the conditions, the pump is always protected. It includes all the automation functions so that whatever our application, whatever our requirement, the complete automation is done, the complete operation is done automatically. So all these functions are included in this panel, plus the design of the panel is completely plug and play, so that if someday some fault is developed, the fault recovery is very easy, as the faulty part can be replaced in minutes and the downtime of the panel is very less. Of course, the fault generation is very rare in case of our panels, as the panel is designed for a million operations. Now let's begin with the inspection of the panel from how it looks outside. Now let's begin with the internal construction of the unit. As you can see that the panel is a wall mounting unit. It is a branded enclosure with IP66 protection. It has a front sticker and display area, user interface area, and a door lock. Let's open the door lock and see how it looks from inside. If you can see, it has a very few parts inside. It has a MCB, which is a incomer supply unit. You connect the incoming power wire to the incomer. You have a power PCB, or it's also called base PCB. Base PCB is the unit which actually takes the entire motor current. So it is a high voltage, high current part. Then it has a transformer. The transformer you can't directly see as it is enclosed inside another box. Then you have control PCBs, control PCB for pump 1 and control PCB for pump 2. As you can see, everything is connected through FRC wires, which are plug and play. So anytime I have to remove one PCB or replace it, it is very easy. I can just pull this wire, remove this PCB and put another one. Please also note that it also has a front sticker, which is a very important part, as it has all the switches inside. So these switches are also connected to the PCB through this wire, which is also a plug-in type wire. So if you have to remove one of the control PCBs, then you just have to remove the two connections, remove the screws, and you can just replace the unit with another controller. Now let's begin with how the panel operates. Let me close it and let's begin with how the panel operates. Right now, as you can see, both the pumps are in standby mode. One pump control area, it has a display which shows the pump condition, whether it is in on mode or off mode, or what condition it is, what is the current is being drawn. It has a arrow buttons which corresponds to the related display. We will understand that in a little while. It has overcurrent, undercurrent buttons, which are for the settings for protection of the pump. Then we have auto hand and on off switch. This is for auto hand operations. In auto mode, the on off switch does not work. You have to press the hand mode. Once you press the hand mode and the unit gets into hand operation, you'll see it starts blinking. It starts showing that something is wrong with the unit. It's not in normal operational mode. It starts showing off. It's not showing it is standby and ready for operation on the sensors. And now you can start it with the on off switch. I can start with the same button, and if I have to stop it, I will stop it with that button. Once this testing and hand operation is over, I can always put it in automatic mode by pressing the auto button. The blinking stops, the unit starts showing standby. The same function and same buttons are available for pump number 2 as well. The design is the same, the buttons are the same, the control is same, the display is also the same, which shows the status and the current for the respective pump. Now let's begin by checking how we do the setting for the unit. The protection unit's setting is the first thing that we will go ahead. So it has overcurrent and undercurrent settings, but they are protected. You cannot directly go and press the overcurrent button and change the settings of the unit. What you have to do is you have to open the lock that is provided for each of these panels. The lock is very simple to remember. It's common for all our units and it is very simple to remember. The code is 1248 from the right side. Let's open the code for this unit. So I keep the overcurrent button pressed till everything becomes 0. Keep this button pressed till everything becomes 0. Once everything has become 0, I press this arrow button once. So the respective display area starts showing 1. I press the next button double times. I press it 2. The next button I press 4 times. It shows 4. And the first button I press 8 times. It starts showing 8. Now I have entered the code and I can change the setting as I want. What if I by mistake went ahead? I wanted 8421, but now I have 8431. No problem, just go on pressing the related button. You will reach 9 and then 0 and then 1 and 2. Now I have entered the code lock. Now I will press the overcurrent button. Let me change the overcurrent setting from 6 to, let's say, 4.5 I want. In that case I have to go on pressing 4.5. Here I have done it 4.5 as overcurrent. Now I want to change the undercurrent setting, which is 0 to, let's say, I made it 3 amperes. So my undercurrent in this case is 3 amperes, overcurrent is 4.5 amperes. So as long as the motor current is between 3 and 4.5, my pump will run. The moment the pump current goes above 4.5 or the moment it goes below 3, the pump will stop and you will get a respective message. Let's try that and let's run the pump. But before that, please note that the pump panel gets automatically locked after 15 seconds. And now again, if I have to change any settings, I will have to enter the code lock and then do the settings. I cannot change the settings directly. Let's try to see how it switches off. As there is no pump connected at this moment, if I go to hand mode and start the pump current taken is 0 amperes as there is no pump actually connected. And after a little initial delay, the pump will trip and it will start showing UC. As it is, the current drawn is below 3 amperes. Let me set the undercurrent settings to 0 again. So what I'm doing, I pressed overcurrent till everything becomes 0. Then I press this button 1, then this button twice, then 4 times and then 8 times. Now my lock is open. I go to undercurrent. I make it 0 so that it works for our demo purposes. Now I leave it for around 10 to 15 seconds and it will be locked again. Alright, it has already got locked and I cannot change the settings now. What I will do now is I will put the unit in auto mode. In auto mode, the fault is gone. It is in reset mode. Both the pumps are ready for action. So we have seen the same method of changing the lock is applicable for pump 2 as well. We can change the pump 2 settings. We can see it, but we cannot change the settings without opening the code lock. So this is the procedure for opening the lock. Now what we will see is how the model actually operates. Let's begin by how the pressure switch 1 is connected, and the unit is a pressure booster application. So when pressure switch 1 is connected, I am saying there is water inside the tank, and the pumps are properly primed. When I switch pressure switch 1, one of the pumps started, pump 2 in this case have started. As long as the current is in the range and the pressure switch is closed, the pump will keep on running. And here I open the pressure switch, you can see the pump stops. Now the next time when the pressure drops and the pressure switch operates, you can see the pump 1 now started and it has taken over the application. The same thing will go on, the pressure switch opens and closes again, the second pump alternating operation will continue. In our case, in our application, the same unit has 2 pressure switches. The second pressure switch is for duty assist. So in the case that one pressure switch is already operated and one pump is running, and we have a condition that the pressure still drops and the second pressure switch operates, let me do that here. The second pressure switch operates, you see the second pump started now, and both the pumps are running when both the pressure switch operates. Once the pressure switch is operated again, after the pressure is required, the pressure is reached, so pressure switch 2 operated again. You can see one pump started, the one pump running reaches the required pressure, and the second pressure switch also operates. You can see the second pump also stops. The next time the cycle will repeat with the other pump. In case there is water shortage and let's say there is one pump running, as you can see pump 2 is running, and what I will simulate now is if the float switch in the sump tank operates and the water level is low, then you can see the running pump will immediately stop and the unit will start showing LTE. That means lower tank empty, and we know with this display that the pressure switch, the float switch has operated and there is no level in the lower tank. The same operation, very similar operation is achieved for the 2 tank controllers or transfer applications. The sump tank operation is as it is. If there is water in the sump tank, you'll get to standby. If there is no water in the lower tank, then of course, as always, it will show LTE and the unit will blink indicating there is no supply in the water tank. Let's say there is enough water in our supply tank. So unit is in standby mode. Now you connect the float switch to the delivery tank, to the float pressure switch 1 terminal. The moment the pressure drops and pressure switch, the float switch in the overhead tank operates, you see the pump starting. When the overhead tank is filled, as I am doing it now, the pump will stop. The next time when the tank is empty, again it will operate. The alternate operation will go on. So this is the 2 tank control mode operation. The same unit can be used for both the applications. Now let's see how the connections are made inside the terminals. Now let us go ahead and verify how the connections are made. The supply terminals, the supply wires are connected to the incomer. So this is a single phase unit, so it has only live and neutral. In case of a 3-phase unit, we will have an RYB connection. Pump 1 and pump 2 are on the power PCB. In 3-phase connections also, the mounting is the same. You'll have 3 terminals here, 3 terminals for pump 2. So pump 1 goes here, pump 2 goes here. Both are connected the same way. Then we have, as it is clearly marked as well, please note all the markings are very clear. Then we have first 2 terminals, as said in a panel state, that which is used for BMS, or in some cases it is used for indication inside the house. After that, the first 2 are pressure switch 1 or float 1, that is for overhead tank float. So for booster sets, the first 2 terminals are for pressure switch. The next 2 terminals are for pressure switch 2. The first is duty pressure switch, the second is assist pressure switch. If we don't have assist, it's a duty standby model, then the second pressure switch connections are left empty, and then the last 2 connections are for some tank level. So this is it. I hope you have a better understanding of the panel now. Thank you for your interest and have a good day. Thank you.